Okay, let's get into this. We're looking at the Apep Nebula today. Think this huge cosmic serpent swirling out there. And we just got these incredible new images from the James Webb Space Telescope. You sent over this article straight from the researchers, and wow, what they found. It really changes how we think about these huge stars, how they die, and, well, how they actually create stuff like us.
Exactly. It's all about these violent star deaths. We're going to unpack what the new data shows and how these, dramatic events shape everything, including the very elements right here on Earth. Inside you, actually.
So, Apep. It's named after the Egyptian god of destruction, this serpent god. Astronomers first spotted it, 5 years ago with the VLT in Chile?
That's right.
And those first pictures showed this massive dust spiral. Looked almost like a snake eating its tail or maybe water shooting from a sprinkler.
Yeah, not quite what they expected.
Right, because usually with binary stars like this, you might expect a neater shape, like a pinwheel nebula, that classic spiral. So why was this one so messy?
Well, that's a great point. Pinwheels are common, yeah. But Apep's structure just screamed energy, chaos. And that pointed towards Wolf-Rayet stars.
Right.
These are some of the most massive stars out there. Right before they go supernova, they violently blow off their outer layers, mostly hydrogen.
Like shedding skin, cosmically speaking?
Kind of, yeah. And what's really key here is when you have two of them, or one with a strong companion, their powerful stellar winds slam into each other. They compress. And right in that collision zone, that sort of eye of the storm, carbon-rich material condenses into dust.
Carbon dust.
And think about this process happening early in the universe. It likely created some of the first carbon dust, the stuff that eventually formed planets and, well, us.
Wow. Okay, so fast forward to now. JWST gives us this new view. It uses infrared, right? So it sees heat. Hot stuff is blue, cooler stuff is green and red.
Exactly, like a thermal camera for the cosmos.
Yeah.
And this new perspective, it flipped the script.
How so?
Well, the initial idea was maybe one really strong Wolf-Rayet star overpowering a weaker companion.
That would make the pinwheel, maybe.
Possibly, or something closer to it. But Webb showed that's not it at all. It's actually two Wolf-Rayet stars. And they're both incredibly powerful, with winds of almost equal strength, almost like two cosmic titans wrestling.
Two heavyweights. So that explains the weird shape. Not a pinwheel, but this wider, almost windsock thing.
Precisely. The equal forces create that broader, more complex structure. The JWST data was just so clear on that.
Amazing. But didn't it show even more? Something about other shells?
Oh, absolutely. It didn't stop there. Further out, Webb saw 3 more distinct dust shells. Fainter, cooler, and get this, perfectly evenly spaced.
Yeah.
All against this backdrop of swirling dust.
Okay, 3 more shells. And didn't people suspect there might be a third star in the system?
Yes, that's been a question for a while. Was that third point of light truly part of Apep or just, a background object?
And the new data settled it.
It really seems to have nailed it. The images show this clear bite taken out of those outer dust shells, like something is carving into them. And the location of that bite, it lines up perfectly with where the wind from that suspected third star would hit.
Whoa, so it's carving a path through the dust. That pretty much proves it's there, interacting with the system, a third sibling.
It's incredibly compelling evidence. So Apep is this complex triple star system.
And all this comes from 2 new papers, right? By Yinuo Han and Ryan White, really rewriting the textbooks here.
They've done fantastic work. Things like how the dust cools, how the background and foreground dust connect. It suggests Apep might be even farther away than we thought.
Which means the stars must be incredibly bright, luminous.
Extraordinarily luminous. And the new computer models they've built, they've managed to figure out the orbits of the inner pair and how that third star interacts. It's precision astrophysics.
So let's bring it back home. Why does understanding a system like Apep, this complex, violent trio, actually matter to, us?
Well, it gets right back to basics. How do the most massive stars live and die? How is essential stuff like carbon actually made and spread through the cosmos? Apep is a unique laboratory for seeing that process unfold. It's showing us the origins of the elements that built our planet, built life, built you.
It's a pretty stark reminder, isn't it? That cosmic destruction, these violent stellar winds and eventual explosions, they're also acts of creation.
Absolutely foundational. They don't just end things, they forge the building blocks. That carbon, essential for everything we know.
So maybe next time you look up at the night sky, remember Apep, that cosmic violence and creation aren't opposites. Maybe they're just 2 sides of the same star-forged coin.